finally, let's take a look at some practice that we can do together. So I'm going to look at two practice with you, and then I'm going to have you try a couple on your own that should sort of mimic these that we're doing together. And you'll notice as we go through these first two practice together, there is a strategy in this practice and in the next practice that I haven't gone through with you, and I did that on purpose because I'd already thrown so much information at you that I didn't want to give it to you before you actually had to use it. So just keep in mind, I wouldn't expect you to be able to do this practice exactly as it is all by yourself until I teach you these other two strategies. So the first thing we're going to do here, this says how many ways can we arrange 20 balls? So that 20 tells me that I'm looking for the coefficient of x to the 20th. We've got 5 boxes, and 5 boxes means when I write my generating function, I'm probably going to have some expression to the 5th, assuming that each box has the same restrictions. And the restriction here is each box must have more than one ball. So what does that tell me? That tells me this part, g of x, means more than one. That means 2 or more. So x squared plus x to the 3rd plus x to the 4th, etc. Now, do I have an endpoint? Well, I mean, an endpoint sort of 20, but really it doesn't say, I mean, we only care about the 20 balls, but it doesn't say I don't have 100 or 1,000 or 1,000,000 balls. So I can just use this ... Now this is an important distinction. The reason for that is this guy can just be the fundamental identity, which is, if you'll recall, if it starts at x to the 0, x to the 1st. Remember, we rewrote that as 1 over 1 minus x. That's why it's important if there's an endpoint or not. So the first thing I would do is write out here's my goal to find x to the 20th of g to the x, and g to the x is this generating function we just talked about how to come up with. Now, here's the part that we didn't talk about yet, I don't think. This part, essentially we're saying, I want this guy, like I said, to be x to the 0. So I really want to take out x squared, but I'm taking it out of the first expression, and the second, and the third, and the fourth, and the fifth. So how many x's am I really taking out? 2 for each of 5, so total of 10. 2 times 5 is 10. So if you'll notice, I'm trying to find, and I know we talked about this part before, is factoring out that x value. The part that we haven't talked about is that because I'm finding x to the 10th, or I have factored out x to the 10th, and I'm looking for x to the 20th, essentially what I can do is I can shift everything over and say I'm really just looking for the coefficient of x to the 10th of this series. Now, why is that important? Because it's going to make it easier for me. I don't have to worry about this x to the 10th. It's gone. I've shifted it over, taking 20 minus 10 to get 10. And now I'm replacing this with the fundamental identity, 1 over 1 minus x to the 5th. From here, this should be like, oh yeah, I remember how to do this because we just practiced. Let's rewrite this as 1 minus x to the negative 5th. What does that tell me? That means negative 5, choose 10 of what? Of negative x to the 10th. Now remember, negative 5 choose 10 is 5 plus 10 minus 1, choose 10, and then negative 1 to the 10th. This guy is also negative 1 to the 10th. Oops. Negative 1 to the 10th, and then x to the 10th, which we don't care about. So really, I just end up with 5 plus 10 minus 1, which is 14, choose 10, because these guys are both positives. This is my final solution. I don't need to find what that is as an actual value. 14, choose 10 is sufficient. I want to do one more practice with you. And again, this is not one you would be able to do all by yourself yet because there's one more strategy that I haven't taught you. again on purpose, because I didn't want to overload your brain before we actually used it. But what I want you to notice is this is almost identical to the question we just did. So there's just one thing that's different, and that is that I have an upper limit, which by that I mean no more than 10 balls. So how does that change things? Well, before I start going through the question with you, remember on the last one, we started out with x squared because it says more than 1, so that's 2 or more. And we were able to just write that as an infinite series to the fifth. And the reason that it was important that it was infinite is I could rewrite that as 1 over 1 minus x to the fifth once I shifted this to x to the 0. So that's not going to be the case this time because my generating function is now going to go to x to the 10th, and that cannot be rewritten as the fundamental identity. So let's take a look at how we're going to write it. First part remains the same. I'm finding x 20th, which means the coefficient of x to the 20th of my generating function, which is x squared through x to the 10th, 5 times because there's 5 boxes. I'm still going to factor out x squared 5 times, so notice that's still x to the 10th. The only difference here is now I'm going to x to the 8th because I've factored out x squared. 10 minus 2 is 8, which means here's my function. I'm finding x to the 10th of this function. Now why is that different? Because I can't use 1 over 1 minus x. I have to use my finite geometric series that says if it goes to x to the 8th, then the numerator is going to be 1 more than that. So notice 1 minus x to the 9th over 1 minus x, still to the 5th power. And again, how am I going to write that? I have the numerator to the 5th power, but the denominator to the negative 5th power. So this is as far as you should have been able to do by yourself. I haven't taught you the next part. The next part is called convolution. And originally I was going to teach you about convolution and then we were going to do this question, but really it just makes so much more sense when you're actually looking at an example. So here's what convolution means. I have more than one function. Clearly, here's a function. We'll call it f of x. Here's another function, h of x. Total, I need how many x's? I need a sum of 10. Okay, so really what that means is we have to look at a case-by-case basis. Let's say I had 5 choose 0 of this guy. Well, if I'm choosing 0 of them and I need a sum of 10, then it must be negative 5 choose 10 of these because I've chosen 0 x's here because I'm not choosing any, which means all of my x's have to come from here, which means I need 10 of them from here. That's case 1. So 5 choose 0, negative 5 choose 10. Hopefully you follow that. Then let's say instead I'm choosing 5 choose 1 of these. Well, 5 choose 1 is great, but that doesn't mean I get 9 from here because how many x's do I have here? Well, if this is 5 choose 1, it's also negative x to the 9th, right? Because there's 9 of them, which means I already have 9 x's. I need the sum to be 10, so how many am I going to get from here? Just 1 x from here. So that's case 2, is 9 x's from f of x and 1 x from h of x. And if you'll notice, that's how I've written it. 5 choose 1, and then why didn't I write x to the 9th? Well, because if you'll recall, we don't care about the x's, we care about the coefficient. So I just said negative 1 because this was negative 1 to the 9th, x to the 9th. I don't care about the x to the 9th. I just care about the negative 1 to the 9th, which is in fact negative 1. So what is my solution? Do I have to keep going? Well, I need the sum to be 10, So what if I did 5 choose 2? Well, 5 choose 2 would mean that I have negative x to the 9th squared. That's 18. I need the sum to be 10, so I don't need to keep going. I'm done with my cases. My solution is the summation of those two. So I'm adding this and this. And you might say, well, no, you're not. You're subtracting. Well, I only subtracted here because this negative 1 made it negative. Then I just did some more simplification. Here's my final answer. I could write minus 25 instead of minus 5 squared. I could go ahead and find out what 14 choose 10 is and then subtract 25 from it. But really, my symbolic answer is just fine. This brings us to the first question that I would like you to do yourself. And I feel very confident that you can do this question because part A is like our first full practice that we did together, and part B is like the second full practice that we just completed, dealing with the balls and the bins. So this is essentially the same kind of question using the same strategies. I would really like you to try both parts on your own. Feel free to copy down the question and then go back to those two practice that we just completed and use those same strategies, because it really is helpful for you to try this on your own. When you're ready, press play to see how you did. So again, I've got 24 identical robots, and that just tells me x to the 24 is what I'm looking for. There's 4 assembly lines, which means when I write my generating function, it's going to be to the 4th power, assuming that each assembly line has the same restrictions. And for part A, at least 3 robots are assigned to each line, which means I'm starting at x to the 3rd. And is there an endpoint? Not for part A. There's no upper limit, so I can write it as an infinite series. So it's going to look like this. So again, x to the 3rd, etc., to the 4th power. I'm going to factor out 3 x's 4 times, so total x to the 12th. Now it gets me that starting at x to the 0, which is 1. All of this can be rewritten as that fundamental identity, 1 over 1 minus x to the 4th. And again, I'm rewriting that as 1 minus x to the negative 4th. This is x to the 12th that I've factored out, so instead of looking for x to the 24th of that function, I'm now looking for x to the 12th because I'm essentially shifting it 12 spaces. So this is what I'm really looking for. And then how do I do that? I say negative 4 choose 12 of that function, and then also I have negative x, or in this case we only care about the negative 1, to the 12th. Well, and I didn't write this part in between, so if you want the part in between, I would then have 4 plus 12 minus 1, choose 12, negative 1 to the 12th, negative 1 to the 12th. So this all comes from negative 4 choose 12, if you'll recall that pattern. Now, 4 plus 12 minus 1, that's where I got the 15. Choose 12. And then this guy is positive 1 and this guy is positive 1, which will always be the case when I have an even number. And so that's my final answer, is just 15 choose 12. For part B, just like on our last question dealing with bins and balls, the only thing different is now I'm going to have an endpoint here of x to the no more than 9 robots. So that's going to be x to the 9th, which means when I factor out the 3 x's, my endpoint is going to be x to the 6th. Let's move those arrows out of the way. So here's my original function. To the 4th, I'm taking out x to the 3rd 4 times, and that leaves me with a finite series that ends at x to the 6th. I still have my x to the 12th on the outside. I now have 2 functions. Before I start doing my convolution, which is where I find the sum, I want to go ahead and shift it. So I'm looking for x to the 24th, but I'm shifting it 12 spaces. So here's what I'm finally looking for. I'm looking for the coefficient of x to the 12th, of 1 minus x to the 7th to the 4th power, and 1 minus x to the negative 4th power. What do I know about convolution? I need the sum to be 12, which means I can choose 0 from my first function, which means all 12 have to come from this guy. So that's 4 choose 0, and then negative 4 choose 12. Or if I choose 4 choose 1, I'm actually adding 7 x's, which means 5 are coming from my second function. And just like in our last example, if I tried to go to the next version and I had 4 choose 2, that would be 7 times 2 or 14, and I just need the sum to be 12. So 14 is too many. So really I just have two cases. Case 1 looks like this. Case 2 looks like this. Again, where did that negative guy come from? Well, because I've got negative, essentially I have 4 choose 1 and then negative x to the 7th, which is negative 1 to the 7th, x to the 7th, which is negative, and then we don't care about the x to the 7th. So that's where that negative 1 came from. So here's my final solution, which I have chosen to reduce or simplify a little bit more. 4 choose 0 is just 1, 4 choose 1 is just 4, and then of course I rewrote my negative 4 choose 12 as 4 plus 12 minus 1 choose 12, and this guy was 4 plus 5 minus 1 choose 5, and that's where I got my final answer. So this would be my final solution. The last one is for you to try on your own, and I have every confidence that you can certainly do this. Keep in mind, I'm essentially asking you two questions. I'm asking you to figure it out for hamburgers and figure it out for hot dogs. So two different situations. So feel free to break it into two parts. When you are ready and you've tried this question in its entirety, press play to see how you did. So first thing I would do is start with hamburgers and say, how would I set this up? Well, I have a total of 12 hamburgers. That's going to be the coefficient that I'm looking for. But there is no end limit on hamburgers because of the 4 sons. We know James gets at least 1 hamburger, but we don't care how many he eats as long as it's at least 1, and each brother gets at least 2 hamburgers. So I don't need to worry about an end point. So if you'll notice, this guy is James. He starts with 1 hamburger. This is all 3 of the other brothers. They start at 2 hamburgers, and there's 3 of them. From here, we're just going to utilize the fact that we really want that first value to be x to the 0. So I'm going to factor 1x out of this and 2 x's out of each of those. So if you'll notice, that's 1x and then a total of 6 x's because it's 2 times 3 or 6 total x's. What you'll notice happens now is I have 7 x's that I've factored out, and this expression and this expression are the same, so I actually have that expression to the 4th power. So that is how I've simplified it. I'm going to continue to simplify by shifting 7 spaces, so now I'm looking for the coefficient of x to the 5th of that expression to the 4th power. Remember, this is just that fundamental identity which turns into 1 over 1 minus x to the 4th, or even better, 1 minus x to the negative 4th. From there, it's very straightforward because we've done this. We know that this just means negative 4 choose 5. And you might say, well, hey, you actually forgot some things. Well, I did, but I didn't. This is actually negative 4 choose 5, and then negative x to the 5th. But negative 4 choose 5 is 4 plus 5 minus 1 choose 5, negative 1 to the 5th, negative 1 to the 5th from here. And so this turns into negative 1 and this turns into negative 1, and they multiply to positive 1. So I just didn't show that step, but then I took 4 plus 5 minus 1, which is 8, choose 5, and so that's my final solution for A, or for the first part, sorry, for hamburgers. Now let's look at hot dogs. Again, hot dogs is going to be set up like our second example we did, because the brothers get at most 5 hot dogs, so there is going to be an endpoint there. So for hot dogs, for James gets at least 3 hot dogs, so 3 or more with no endpoint in sight. The brothers get at most 5 hot dogs, but notice their lower value is they could end up with 0 hot dogs, but they can get at most 5. So there's 3 of those because there's 3 brothers. This guy has an endpoint of 5. This guy doesn't have an endpoint. So x to the third, x to the fourth, on to infinity. I'm going to factor out x to the third just one time. This guy's fine just as he is. Factoring out an x to the third means I'm actually looking for x to the 13th of that fundamental identity, which turns into 1 over 1 minus x. And this guy is a finite series written as 1 minus x to the 6th, 1 minus x all to the 3rd power, and so that's what it looks like. X to the 13th of 1 minus x to the 6th, and if you'll notice, I just combined these two, 1 minus x to the negative 4th. From here, it's really just putting it all together. I'm looking for x to the 13th. This is that convolution part where I'm saying, hey, I could choose 0 of these, which means all 13 come from here. So negative 4, choose 13. I could choose 1 of these, which means I'm actually getting 6 x's, which means the other 7 come from my second function. Or I could be getting 3 choose 2, and 3 choose 2 would give me 6 times 2, or 12, which means only 1 comes from my other function. Then I just did a little bit of simplification. So this expression represents hot dogs. My final solution is essentially me multiplying those values together, because that's what we do when we have 2 options. So 8 choose 5, notice, is being multiplied by this whole expression. This is my final solution. That's the only part that you wouldn't have maybe known how to do already, but the other 2 parts you should have been just fine with. This slide and the next slide are really just a summary slide, just to make sure you remember how to look at the generating function, the summation, and how we represent it. So it's going to be something really good for you to fill out and come back to. I'm not going to talk through each of these because Lord knows this is the longest video I've ever made. Anyway, so I'm just going to kind of show you the answers for each of these. Again, I encourage you to, if you get stuck on these, go back to section 9.2, the beginning of this video, which was about an hour ago, and look at how I can represent each of the generating functions as a summation and how we actually write them when we are solving to find the coefficient. So this is our first page. Again, some great review. And my next page, again, I encourage you to try to fill out the unknown parts first before I give you the answers, and then go back and check your answers against mine. But again, not a bad way to summarize. Make sure you understand how everything ties together.